Hey guys, welcome to a kind of a what you need to know video for level 2 mechanics. This is going to be a study guide video for our upcoming mock exams in week 7 or week 8. So what we're going to be starting off, with the general 4 kinematic equations of motion, okay? So 4 kinematic equations of motion. You should be pretty familiar with this. You can find this on your formula sheet. It's given in the exam, but it's just to recap, okay, so you know exactly what they are and exactly what they mean, okay? So you should know the 4 kinematic equations. Vf equals to Vi plus At. So also D equals to Vi plus Vf over 2 multiplied by T. And also you should know that D equals to Vit plus half At squared. And the final one, you should know that Vf squared equals to Vi squared plus 2Ad. Alright, so where the Vf is final velocity, where Vi equals to initial velocity. Vf is final velocity, Vi is initial velocity, where d is distance, and A equals to acceleration, and finally, what am I missing? Finally, the T equals to time. So final velocity is measured in meters per second. Initial velocity is also measured in meters per second. Distance is always measured in meters. Acceleration is measured in meters per second, and time is always measured in seconds. So these are the 4 kinematic equations of motions that you will need to use. So the application for these types of questions is, for example, they're going to give you 3 out of 4 of the variables, and they're trying to give you these 4 equations, and you have to pick and choose the correct equation and in order to find what the missing variable is. So they give you 3 out of 4, and they want you to find the 4th variable. So for example, they give you Vf, Vi, and T, and they want you to find acceleration. So you use Vf equals to Vi plus At, and then you rearrange the formula for A. And it's just like different types of questions. So we're going to run through a few simple achieve questions to start off with, achieve merit questions that involve using the 4 kinematic equations. Alright guys, I'm going to be covering one example from a past year paper with the examples of the 4 kinematic equations of motion, okay? So we're going to be worrying about part B here, okay? I'm going to read out the question, okay? So the world record in long jump was set by Mike Powell in 1991 in Tokyo. The diagram below shows Mike's jump at the highest point of flight during the projectile motion. Alright, so we're not going to worry about A for now, okay? We just don't need to worry about that too much. We're going to go directly to B. During his run-up, he started from rest and covered the distance of 12 meters in 3.4 seconds. Find the acceleration for this part of his run-up. Alright, so the first thing to do in these types of questions, you need to be noting down what variables you have. So it says during his run-up, he started from rest. When you say start from rest, you know that at the start of his run, so the initial velocity was 0 meters per second. So you can immediately note down that Vi is 0 meters per second. You also note down that he covered the distance of 12 meters. So distance measured in meters, variable is d. So you can write down d is 12 meters. And in 3.4 seconds, time is measured in seconds. So you can write time equals to 3.4 seconds. And the question asks you to find the acceleration. So acceleration we want to find. Alright, so now we've done the easy part. We've got to go to do the little bit harder part now, which is to identify which 4 equations do we need to use in order to solve this question. So looking at the equation, which 4 equations has Vi, D, T, and A, and nothing else? So we want an equation that only contains Vi, D, T, and A. So you should find that the only formula that should satisfy this is D equals to Vit plus half At squared. That should be the only formula that satisfies this question. It's because it has D, and D, Vi and Vi, and T, and A. So you'll have all 4 variables we need in this formula, so therefore we're going to be using this formula to find our answer. And now all we have to do is a matter of substitution, okay? So D equals to 12, so 12 equals to, Vi is 0, so 0 times of 3.4. So 0 times of 3.4 plus half of A, we don't know what A is, so we just say A times of 3.4 squared. And now all you need to do is a bit of rearranging, okay? So 0 times 3.4 is 0, and half of, so basically A would just be 12 divided by 0.5 times 3.4 squared. And that should give you your A. And if you plug everything into your calculator, you should find that your answer should come out to be A equals to 2.1 meters per second. Alright, and that's only just an achieved question, achieved mark there. So that was an example of using a kinematic equation using using 4 variables to find a missing variable. I'm going to be covering one last example. Roll it. Alright, so we're going to be covering two more questions involving the kinematic equations and the 4 different variables that you will need to find the correct answers, okay? So we're going to be reading out the question here. So we should have Hiroshi travels on the Japanese N700 Shinkansen bullet train, which is a high-speed electric train with a top speed of 300 kilometers per hour, which is 83.3 meters per second. Its maximum acceleration is 0.72 meters per second. The maximum acceleration occurs just when the train has started moving. Assuming it could maintain a constant acceleration of 0.72 meters per second, determine the time it takes for the train to reach its maximum speed from stationary. Okay, that's very important. From stationary. Okay. Once again, we're going to be noting down what we know and what we need to know. Okay. So, what we have an acceleration we know is constant acceleration of 0.72. Okay, and it says reaches maximum speed from stationary. Okay, so it's starting from stationary, so therefore our VI would be 0 meters per second. Sorry. VI is 0 meters per second. And we also know that the maintain constant acceleration, so and we need to find T we need to find, we don't know. And determines time. The maximum speed, a top speed is 83.3 meters per second. So our VF we need to find is 83.3 meters per second. Alright, so now looking back at your formula sheet, which equation of motions has A, VI, T, and VF, and nothing else? Alright, so you should be looking at your equations. Okay, so you should see that the only equation that satisfies this is VF equals to VI plus AT. Has VF, VI, A, and T. Alright, so now we're just going to be plugging the numbers in. Okay, so 83.3 equals to VI is 0. 0 plus of 0.72 of T. So now all you need to do to find T, so 0 plus anything is still, the 0 is redundant, so we're just going to get rid of that. So 83.3 divided by 0.72 will give us our T value. And if you plug that into your calculator, you should find that your T value should be coming out to be 115 seconds. Sorry, 115.7 seconds. And that should be your final answer for this question. And that's a simple achieved question there. Right, this next question is also involves the kinematic equations, and we'll cover this one as well. It's a merit question. So calculate the distance it will cover during this time. Right, so now we need to think a bit more now. So now we have time, we have all 5 variables, and we need to find distance, okay? So you can really pick and choose which one you want to use, but it's best to note down what you have. So acceleration is still the same. VI is 0. T we now know is 115.7 seconds. And our VF is 83.3 meters per second. And we have our distance we want to know. So you can pick and choose which one you want to use. It really doesn't matter since you have all 5 variables. You can choose what you want to use. Okay, so let's just say we use VF squared equals to VI squared plus 2AD. So our VF is 83.3, so 83.3 squared equals to VI is 0, so 0 squared is still 0, so it just becomes 0 squared plus 2 times of acceleration, which is 0.72, times of distance we don't know. So now it just becomes a matter of rearranging the equation. So 83.3 divided by 2 times of 0.72, and that should give us our D value. And once again, if you plug into your calculator, your distance should be coming out to be 4,820 meters. It should come out to be 4,820 meters. Alright, so the reason I decided to use VF squared equals to VI squared plus 2AD is because this equation doesn't have time, okay? So assuming you didn't get the first question, so assuming you didn't get A correct, you can still get B correct, assuming you used the equation I just used, okay? So that's assuming you don't have T. But if you did find the T in the last question, you can use any equation you want, okay? Because you have all 5 variables. Alright. In the next video, I'm probably going to start looking at about projectile motion. So stay tuned for that. Right, so the very basic skill in projectile motion is being able to find the horizontal component and the vertical component of the velocity when given the angle theta and the instantaneous velocity, okay? So it's very important that you know this skill off by heart, okay? Because if you cannot find the horizontal component and the vertical component, then it becomes very difficult to access good grades in this part of the questions. Because in projectile motions, most merit and excellence questions come based on finding out the horizontal and vertical components. So it's essential that you know how to do this, okay? Alright, so this is just basic trigonometry, okay? So it's a bit geometry as well. So let's just see this question here. So Marurama is a long jumper. She runs down the track and jumps as far as she can horizontally. Her takeoff velocity is shown in the diagram below. You can assume there is no air resistance. So it tells you the acceleration due to gravity is 9.8 meters per second. Show the horizontal component of her initial velocity is 6 meters per second. Okay, so the first thing to do here, okay, you're going to make a right angle triangle. Okay, so if we dot this back down, this will be our right angle triangle. And this will be our angle of 20 degrees, angle theta we know. So we want to find a horizontal component, okay? That's the horizontal component, which is h. We can just say it's VH or h of x. It doesn't matter, but just say VH. And I will say that our vertical component is V vertical, so velocity vertical, okay? Alright, so notice that it's just basic trigonometry. Okay, so you have 20 degrees, this is the opposite side, this is adjacent, and this is hypotenuse. So you want to find the horizontal component. Okay, so horizontal component, we have the hypotenuse, and we have the we need to find the adjacent side. So what involves both A and H? Okay, so we have our Sol, Ka, and Toa. Alright, so which of these 3 rules contains both A and H? So as you can see, it's the Ka rule. Okay, so the Ka rule here is what we're going to be using. So cos of theta, which is 20 degrees, is equal to our A over our H. So A is our VH over 6.4. So cos 20 times 6.4 should give us our VH. If you plug that into your calculator, you should get something very similar to 6 meters per second. So sorry. Remember, your calculator should be set to degrees. Very important, okay? So cos of 20 times of 6.4. Yeah, that gives us your answer. VH comes out to be 0.101 meters per second, which can be rounded off to rounded to 6 meters per second. Okay, so that's how you figure out the horizontal component of the velocity. And for a vertical component of the velocity, it's basically the same thing but using a different rule. Okay. So this time, okay, we need to find our V vertical, okay? So that's our opposite side, and we have our hypotenuse. So what involves both O and H? Sol, Ka, or Toa. As you can see, the Sol rule has O and H, so we're going to be using the sine rule in this case. So we're going to say that sine of 20 equals to O over H, so O, which is our VV over 6.4. So this time, our VV will be sine 20 times 6.4. So sine 20 times 6.4. And you should see that your VV should come out to be 2.19 meters per second, and that rounds to 2.2 meters per second. In terms of grading for these questions, both of these questions are just simply achieve level questions, okay? It's not that difficult, okay? It's just basic trigonometry skills in order to find the vertical and horizontal velocities. For the next clip, okay, I'm going to be looking more at projectile motion, okay? And possibly some more calculation questions, okay? Alright, let's roll that. Alright, so a common question they give us, like, basically almost every year, they'll give you something similar to this question, which is in the projectile motion section, which is being able to calculate the total distance traveled given a instantaneous velocity and an angle theta, okay? So that's also known and referred to as the range, okay? The range, which is the total horizontal distance traveled by the projectile. Alright, so how are we going to be figuring out the horizontal distance traveled? Our first steps, okay, is always to be finding the horizontal and vertical component of the velocity. That's very important. So as you can see, part A here shows the horizontal component of the initial velocity was 23 meters per second, okay? So as you can see, the instantaneous velocity was 30 meters per second, and the angle theta is 40 degrees. So if we want to find a horizontal component, okay, once again, we're just going to be using our cos rule. So cos of 40 is equal to horizontal component over 30. So cos 40 times of 30 equals to VH. And some calculator work here should come out to be an answer very close or exactly to 23. So cos of 40, and we multiply that by 30. That gives us an answer of 22.98 meters per second, which rounds to 23. Alright, so now we need to calculate the range, okay? So when I say the range, okay, that means the total horizontal distance traveled, like I said a few minutes ago. So how are we going to find the horizontal distance traveled? Okay, so this equation is essential that you remember this equation, okay, because it's not given to you in the exam, okay? So the range, okay, we're going to denote that as small r. So small r is equal to the horizontal component times by the total time total, okay? So that's how you're going to be figuring out your total range. So we already have our VH, so our VH we found out, it's already found that out. However, we still haven't found our T total. Alright, so how are we going to find our T total in the projectile motion? So in the projectile motion, okay, note down that it's a parabolic parabola, which means the first half is always symmetrical to the second half, okay? And that means the time it takes for the ball to reach halfway is same as the time taken for the ball to reach halfway to the finish, okay? Alright, so we're going to be figuring out, so basically what we're going to do here is going to figure out how long will it take to reach the max height, and then multiply that time by 2 because the parabola is symmetrical. So same on both sides. Alright, so you know that when I say the max height, okay, that's referring to vertical distance, okay? So the ball's traveling up, a maximum height. A height refers to a vertical distance. So we can't actually substitute our VH in this scenario. So we actually need to find what our vertical velocity is, okay? And we have to use that in terms of our calculations. So we're going to be using the sine rule to find our VV, okay? So sine of 40 would be equal to VV over 30. So sine 40 times of 30 equals to VV. And if you plug that into your calculator, sine of 40 times of 30, that should give you your VV as 19.28 meters per second. Alright, so now that you have your VV, now you can use this VV and some other variables, and you can figure out the time taken for the ball to reach the maximum height. So we need to note down what we have, okay? So we have our VV. So this VV occurs when I kick the ball. So in this case I throw the javelin, context. So in this case I'm going to be throwing the javelin, and the 19.28 meters per second is immediately occurs after I throw it. So as soon as I throw it, it has a vertical velocity of 19.28 meters per second. And what does it mean when I have immediately have 19.28 meters per second? That means our VI is equal to our VV. So VI is equal to 19.28 meters per second. Okay, so we also know that there's a component of gravity acting downwards on the javelin. So we know that because the javelin is traveling upwards at 19.28 meters per second and the gravity is acting downwards, they're opposing each other in opposite directions. So therefore our acceleration is not positive 9.8, but it's actually negative 9.8, where the negative represents the change in direction. So acceleration is negative 9.8 meters per second, And we also know that our VF is always 0 meters per second. It's 0 meters per second because at the maximum height, the ball momentarily stops at the maximum height. So when the ball is at the max height, the vertical velocity is 0. And we want to find what our time is. So our time we don't know. Alright. So what equation of motion has VI, A, VF, and T? Should find that the VF equals to VI plus AT is the equation we have to use. So we just need to plug some numbers in. So 19.28 equals to, well, no, sorry, that's wrong. So 0, equals to 19.28 plus AT, which is negative 9.8 times of T we don't know. Alright, so now in this case, we're just going to be dividing 19.28. So T would be 19.28 over 9.8. So if we plug that into a calculator, you should find that the time taken should be 1.967 seconds, okay? However, that's not your total time, that's your half time, okay? So that's your half time taken to reach the maximum height. But because the parabola is symmetrical, you're going to multiply this time by 2. So we're going to multiply the time by 2. And you should get that your T total should be equal to 1.967 times 2, which is equal to 3.935 meters per second. Not meters per second, seconds in time. So now, using all your formulas together, you can calculate your range. So your range would be your VH, which we found is 23 multiplied by 3.935. And if we multiply these two together, you should find that your final answer should be coming out to be, range should be about 90.5 meters. So we're going to write 90.5 meters as our final answer. Alright, in terms of grading for these types of questions, okay, usually these types of questions are excellence level, but sometimes they might put it down to merit, okay, so you never know, okay, so basically, usually it's excellence, okay, usually like, let's say 80% of the time it will be an excellence question, but sometimes, let's say 20% of the time it will be a merit question, okay, so it's important to keep that in mind, okay. Alright, so in the next part, I'm going to be covering whether obstacle is going to go past another obstacle of a certain height. Alright, well, I'm going to be covering whether a ball kicked at a certain instantaneous velocity and a certain angle theta from the horizontal component, will it go over a certain obstacle of a certain height and a certain distance away. So in this question, Ernie's son, Jacob, kicks the ball towards Ernie in the garden. Ernie is 1.75 meters tall, and Jacob kicks the ball with a velocity of 24 meters per second and an angle of 36 degrees to the ground. Jacob is standing 35 meters away from Ernie. Will the ball hit Ernie or go over his head? In your calculation, start by showing the horizontal component of the initial velocity of the ball is 9.4 meters per second. Okay, so in this question, okay, so once again, we're just going to start by finding the horizontal component of the velocity is 19.4 seconds. So if you still don't know how to do this, go back into the video, rewind a little bit and watch that part of the video where I explain how to calculate this, but I'm just going to speed along with this part. So we're going to say cos of 36 times 24 equals to the VH, okay? If we plug this into our calculator, so cos 36 times of 24, that should give us our VH should be 19.42 meters per second, which rounds to 19.4 meters per second. Alright, so now, okay, so remember what I said in the previous video where our range is equal to our VH times our total time, T total. Remember when I said this, okay, in the previous example? We're going to be using the same concept, okay? So we know Ernie is 35 meters away from Jacob. And because he's 35 meters away from Jacob, we can substitute our range as 35 meters, because that's when the ball is going to be at Ernie horizontally, okay? So if we substitute range as 35 equals to our VH is 19.4 times of T. So if we do this, we'll get our T should come out to be 1.804 seconds. So basically, what does this tell us? So basically, 1.804 seconds after Jacob has kicked the ball will reach the position of where Ernie is. Okay. So basically, what we're trying to find out is what is the height at time is 1.04 seconds. Oh, sorry, not 1.804 seconds. What is the height of the ball at that time? Okay, so the next step, okay, is also relatively simple. Okay, we're going to be finding the maximum height and how long it takes to reach the maximum height, okay? And to do that, we'll need the vertical velocity. So we're going to be saying sine 36 times 24 equals to VV. So VV, sine 36 times 24, that equals, so VV equals to 14.11 meters per second. Alright, so like we said in the last video, okay, I'm going to be using equations of motion. So VF equals to VI plus AT. So VF we know is 0 equals to our initial 14.11 plus negative 9.8 times of T. And if we rearrange, you should find that this T, we'll say T, this is TT, no, we'll say this is T1. So T2 equals to comes out to be T2 comes out to be 1.4 we'll do everything to 3 decimal places. So 1.439 seconds. Okay. So notice, okay, so this is the height we need to find. The height at that time we need to find. And this is the time to maximum height. So now we can immediately see that our actual height we need to find comes after the maximum height. So T1 comes after T2. Okay, that should be pretty obvious from our calculations. Right, so now we need our next step is to be finding our maximum height. Okay, our maximum height, our maximum height. Okay, so we're going to be using a formula D equals to VI plus VF over 2 times of T. So we're going to be using our same variables. Okay, so D equals to VI, we know is 14.11, plus VF, we know is 0, divided by 2, times of the time, which we just found was 1.439. And if we plug this all into our calculator, so 14.11 divided by 2 times of 1.439, that should give us, our distance should be 10.15 meters. So max height, so max distance is 10.15 meters, okay? Alright, so now we need to find out how much does the ball drop in between the T2 and T1, okay? So basically, we're going to be using another equations of motions, okay? So we're going to be using, so this time we're going to be calculating from the max height. So from imagine this is our parabola. Oh, that's a pretty bad parabola. Okay, that's pretty bad as well. But we can just say it's here. So we know that this is T equals to 1.439 seconds. And we need to find somewhere, let's say somewhere here, where T equals to 1.804 seconds. We need to find what is this height here. So what is this height here? So we know that this height, so the max height, we know that this one is 10.15 meters. And we need to find out how much it drops between these two times, okay? So we're going to say T2 minus T1, other way around, sorry. T1 minus T2, and that equals to the time between, okay, we'll say that equals to T3. So if we say 1.804 minus 1.439, That should give us our t3 as 0.365 seconds. Alright, so that's our time, what we're going to be using, and we're going to be finding out how much the ball drops in terms of height. However, we can't do that straight off the bat, okay, so figure out what we have, okay? So the ball is starting from max height, so this time our VI is 0 meters per second. Our VF, we don't know. Our acceleration is now positive 9.8 because it's acting in the same direction, because it's both going downwards now. So A is positive 9.8 meters per second. Our distance we also don't know, and our time we know is 0.365 seconds. So if you notice, okay, looking at your equations of motions, we can't actually directly go to D at this stage, okay? We need to find our VF first, okay? So we can find out our VF pretty easily. Okay, we can say VF equals to VI plus AT. So VF we don't know, so VF equals to VI 0 plus of acceleration times of time. So if we plug that into a calculator, you should find that your VF should come out to be 3.577 meters per second. So now you have a VF, and now you have everything you need to find your distance. So now you can say that D drop is equal to VI plus VF over 2 times of T. So D equals to VI we know is 0. 0 plus of VF we know is 3.577 over 2 times of our time is 0.365. So now we just plug into our calculator once again. So 0.635. We should get our distance as 0.652 meters, okay? So basically what is this? So this is the distance that it dropped. So from 10.5 meters, it has dropped 0.652 meters to get to our new height, okay? So the total distance dropped is 0.652 meters. So therefore, our final calculation is 10.15 minus 0.652. Okay, that gives us so 10.15 minus 0.65. That equals to 9.498 meters, and that is way higher than 1.75 meters. That's much higher. So you can just say 9.498 is much larger than 1.75. Therefore, goes over his head. Okay, that's all you have to say. And that should be your final answer. So these types of questions are most always excellence level questions. Okay, I can be pretty sure of that. Okay, it's basically like 100% of the time this will be excellence level questions. Okay, it's not So I hope you understand exactly what I was doing this entire time. If you don't understand, please leave them down in the comments. I'll answer your questions and theories below. But in the next video, I'll be covering some more theory parts of projectile motion, or roll it. So when it comes to the explanation part type of questions, when one main question we are looking about is when the question asks you to explain the horizontal component is not changing. Okay? So that's the important thing that we have to explain sometimes. So for example, this question right here. So after a while, ruler is rolling at a constant speed. He throws the ball vertically upwards, and area resistance is negligible. Where will the ball land? Okay. So when he throws the ball vertically upwards, the only force acting on the ball is the force of gravity, which is acting downwards. There are no horizontal forces acting, and because there are no horizontal forces acting, the ball will land in the exact same spot of where he threw it. Okay. So it's important to note down. Okay, so this is how we're gonna word our answer. We just say that the ball will land in the same place as where he had thrown it. Now we explain. So we say this is because the horizontal component remains constant as there are no horizontal forces acting. This means only vertical so what I've said here is I'm going to say the horizontal component remains constant because there are no horizontal forces acting. So therefore, this means that there are only the vertical component and the gravity in play, okay? And that means that the ball will experience none of the horizontal movement. So this is a very common question that they ask in the NCAA exam, okay? It's to explain the horizontal forces acting, okay? So just remember always there's the horizontal forces, there are no horizontal forces acting, so therefore the horizontal component remains constant the entire time. Like usually these questions are always merit questions, and it's not a very difficult merit question, okay? It's pretty straightforward, okay? Just say horizontal component remains constant and why it remains constant. For the next question, I'm going to be covering a few more theory type questions that they commonly ask in the projectile motion questions. Roll it. Alright, so I'm back. So some important takeaways for the projectile motion. Some very important points we need to remember is we'll just write these down. So number one, we note down that a horizontal component is always the same, while vertical component is affected by gravity. Alright, so these are just really important points you need to remember. So acceleration is always 9.8 meters per second, acting downwards. And number three, in terms of we should say that number three, so parabolas. So when you have a parabola, they are always symmetrical. It's always symmetrical unless the projectile motion starts at a certain height. So what I mean by that is, for example, this would be a symmetrical parabola. So for example, I kick the ball, and this would be a symmetrical parabola. However, for example, in this case, this is not a symmetrical parabola, okay? It's not symmetrical because I'm starting at a certain height. This h above the ground, okay? So this is the h when it hits the ground. And our starting point is higher than our landing point, so therefore, if I drew a line there, the left side does not equal the right side, so therefore, in this case, the parabola is not symmetrical, okay? So in this case, So in this case, you need to carry out a separate calculation. So for example, you found the time to reach the max height. You found the time to max height. In this case, you can just multiply by 2. However, in this case, you need to separately use the VI and VF and separately work out what the second half time is. So for this case, you found out the first half of time, but then you need to find the second half of the time, okay? So that's what I mean by when I say parabolas symmetrical, unless it states that it's not unless it's not symmetrical, as I say. Alright, so number 4, okay, so gravity is the only force acting, okay? Always, okay, so only force acting is gravity, no horizontal forces, okay? Just need to remember this, okay? Very important. Okay, so when you're answering the questions, okay, you can say always different, okay? Alright, number 5, okay, so number 5, horizontal and vertical components are separate. Okay? So you can separate these two, okay? So one's vertical component, one's horizontal component. They're both two different types of information, okay? So when you're answering the questions, you can split it up into horizontal component and vertical component informations, okay? Do not combine them, okay? And do not use, very important, do not use the instantaneous velocity. Okay, do not use that instantaneous velocity, because that is incorrect. Okay, the instantaneous velocity should not be the instantaneous velocity should be used to calculate the vertical and horizontal velocity, and it should not be used in any type of calculations unless you're calculating the vertical or horizontal component. Okay, very important. Okay, very important to remember this. Okay. Alright, so these are pretty 5 general points that you have to remember, okay? So for the projectile motion, so they're always traveling in the parabolic shape, okay? And so just one final question I really want to go over is drawing the diagrams, sometimes for the vector diagrams, okay? Sorry, I don't have a very good diagram at the moment, but I'll try to get a better diagram, hopefully. Okay, so for example, this is the flight of the ball, and it wants you to draw the instant, the horizontal and vertical velocity at some points. Okay, so when I start here, I'm gonna have a vertical velocity. Sorry, the drawing is not very good. Okay, and a horizontal velocity VH and VV. So for example, as the ball goes into a different height, the vertical velocity will decrease. However, the horizontal component will stay the same. Okay, so VH, this will be VH here. And as we go, the vertical component is going to get smaller and smaller. So when I get here, the vertical component is going to be getting smaller, while the horizontal component is always going to just stay constant. It's going to stay the same, okay? And at the max height, very important, the max height, there is no vertical component, and there is only a horizontal component. And the horizontal component is the exact same as the start, okay? When we come back down, okay, there's gonna start being a vertical velocity in the opposite direction. So for example, this is point A, and this is point B. So if I draw a line here, and this distance is equal, they're equal. That means this vertical velocity acting upwards is equal to this vertical velocity acting downwards, and that's because the parabola is symmetrical, okay? Basically the same on both sides, except one is acting in the opposite direction. And once again, the horizontal velocity will not change, okay? That's too long, sorry. The horizontal velocity does not change. And as we go down, okay, it's going to get bigger and bigger, but in the opposite direction, but the VH stays constant. And when it hits the ground, okay, it's gonna be the exact mirror opposite of what we had originally. So we're gonna have our VV acting downwards, but our VH is still acting in the same direction here. That's too long. So our VH is acting here, and our VV acting here, okay? So that's basically how you would draw the diagrams, okay? They sometimes will give you these types of questions to make you draw the diagrams, okay? They usually only achieved or merit type of questions, but I just thought it was really important to go over it and understand the concepts, okay? Alright, so I think that's it, okay? So thanks for watching this projectile motion and projectile motion plus sorry, what am I doing? Projectile motion plus equations of motions video. Hope you enjoyed, and I'll see you all in the next one. Thank you. Bye.